So today's discussion, we're going to talk about limits of functions. So last time what we had all about functions, we're going to apply one of the properties of functions, and these are limits of functions. So about limits. So, and this is what we're going to talk about today, okay? Specifically, we are going to have graphical and numerical introductions of limits of functions. The existence of calculus depends on the fundamental concept called limit. Moreover, limit serves as the bridge to the gap between pre-calculus. And what are these pre-calculus? Algebra, trigonometry, and analytic geometry. So, bridge to the gap between pre-calculus and calculus. Um, Derivatives and integrals, which are the main ingredients of calculus, are based on the concept of limit. Its notion develops to a more useful concept called continuity, and then eventually the derivative and integral. So today we're going to explore the notion of limit of a function based on graphs and numerical values, and then its mathematical definition. But focus will be on the discussion of algebraic techniques for finding limits of functions and continuity of a function. Okay? So, calculus relies on the notion of limits. Perhaps it is the reason why it is sometimes defined as the study of limits. That is, limit of a function and limit of an area, as what you had in our introduction to differential and integral calculus, no? Meaning on calculus, when we had an overview. So today, again, we are going to introduce a more detailed description of the concept of limit. So we are going to begin with the visual notion of limit of a function and then estimate it numerically. So these approaches proceed in stages that eventually lead to a precise definition of limit. So we have limit of a function, graphical approach. Graphical approach of limit of a function. In pre-calculus, so again, what are those that are under pre-calculus? Algebra, trigonometry, analytic geometry, and other basic maths, no? So, in pre-calculus, given a value of x, so given, normally this is what we have, given a value of x, say x equals a, and this is in the domain of, let's say, of the function of, let's say, of f. So that is our function f. The corresponding value of f of x is determined. So that is, we are concerned with f of a. Yan. So that is what is to be determined, no? So normally that is what we do in the function. If you are in pre-calculus. Now in calculus, so we have much concern, not just on the function value at x equals a, but also on how the function behaves at the vicinity of what? Of x equals a. So that is given values of x that are in the domain of, let's say, the function f approaching, and these values approaching the value x equals a. So meaning approaching a, and this a not necessarily in the domain of f. A not necessarily in what? In the domain of f. Again, a can be in the domain of f, but not required. A can be not in the domain of f. What is important, those numbers that are in the vicinity of x equals a, they are in the domain of f. Okay? So, what we do, we seek the number that the corresponding values of f of a, f of x approach to. So that's what our concern in calculus. So again, in pre-calculus, we're after the value of the function normally at x equals a. And of course, we want your a to be in the domain of f. But in calculus, we're interested with those what? With those values that are in the domain of f and how they behave near x equals a. Okay? As these values that are in the vicinity, either to the left or to the right of x equals a, when they go or when they tend to approach the value of x equals a, again a, not necessarily that the function is defined there, but the values get closer and closer. So what is happening to the values of f of x? No? So where do the corresponding values of f of x approach to? So that's our concern. So to illustrate these things, so graphically, so we have this. Let's say in pre-calculus, so this is our concern. Y, x, let's say I have x equals a here. So a, possible that it is in the domain, possible that it is in the domain of f. So it's like you have this graph, for instance. So let's say that is the graph of the function. So this is my y equals f of x. And this is where we are concerned. Our concern is on this point. Then this point is in the domain of f. And we want to know how the values of the functions are, let's say, where they are approaching, no? Where they are try to go, no? As your x goes here from the left or goes here from the right, your x values get closer and closer to a. So what is happening to the y value, to the y values. Yeah. What's happening? Okay? So, in this case, A is in the domain of F. But it is also possible that your A is not in the domain. So, in general, what we are interested just with the behavior of f of x. What is the limiting value? No? Where does it go as your x gets closer and closer to x equals a? So that's what we want to know. So in this approach, by the way, I want you to have a concrete understanding of what limit is. Now, it is easy to compute actually limits, but how to understand limit, the concept of limit, that is not what easy to understand. No? So I want you to understand the difference between function value and the value that is just being approached. If there is something, or if there is really a number that is being approached, because not all the time there is. Later you will be hearing about what we call limit does not exist. So here, I'm going to have a hole. I'm going to have a hole here. Yeah. So, a hole. Let's say this is a hole. So meaning, this is a function where it is undefined at that value of x, because that is a hole. For this to be really whole, I am going to cover it by, I want it to be green so that it will not really be seen. More color, I think. So that it will really look like open. So this is really open, okay? So that's a hole. Again, what is this point? Hole. So meaning the function is not defined there. So that is our x equals a, no? Now, in this case, our a is not an element of the domain of f, of the function f. Now, what we want to know, how is f behaving? Where does our f go? Or in what value does it go once your x gets closer and closer to a from the left and from the right? So meaning, as I travel along this curve, go from the left going to a, from the right going to a, will I reach a certain position, whether it is a hole, meaning whether it is a trap, whether it is a manhole there. What is important, I will able to reach that. Will I able to reach that? If I will able to reach that, then we say that there is a limit. So that's what we mean. So, of course, if the function is defined there, no problem. For sure, the limit will exist. But if you have a case like this, will still the limit exist? Actually, yes, no? I will still reach this, although it's a danger spot, no? But at least I can still go there. But the function is not defined there. And this is my limiting position as I travel from the left and from the right. So that is what we mean by limit graphically, or the visual form of a limit. Or if there is no spot where I can reach or I will go as I travel from the left and from the right, so we say that the limit does not exist. So in this case, we say limit as x approaches a, either from the left and from the right, meaning as I travel along the curve from the left, from the right, going to a, x equals a, so I can reach a certain number. Normally, we call that number L. The limit as x approaches a, so is what? Of f of x is L, meaning limit exists. Limit exists. But it is also possible that the limit does not exist. Like for instance, if my behavior is like this, I'll just have freehand, no? Because if I'm going to have it using ruler, it will take much of our time. Okay? So it's all right even it's not really straight. So let's now have this graph. So let's say I have this graph. Yeah. And I have this graph. It goes there. And then I have also a graph like this. Yeah. So meaning, there is a line that is a gap between separating the two. In your Gen Math, you study this. This is called actually vertical asymptote. Yeah. Vertical asymptote. Okay? And this is our x equals a. As I travel along this curve, I will travel. Yan. So, as I travel along this curve, going to x equals a, yan, where will I go? Or where does the value of the function go? It keeps on growing. So, meaning it's not attaining a number. It doesn't reach any number. From the right, same behavior. As I go, or as I travel along the curve, I keep on going down. So, I am not reaching a specific number. So, in this case, we say that the limit of f of x, as x approaches a, does not exist. Okay? Graphically, this is how it looks like. One possible case for the limit not to exist. So in other words, limit is cannot always be attained, no? As a real number. It is possible that you won't have a limit. Actually, limit from the right is going bigger and bigger, and we denote that by positive infinity. I mean, from the left, it goes bigger and bigger, positive infinity, which means it's getting bigger and bigger, so there is no limit. From the right, it goes down. It keeps on decreasing. Okay, so it's going to be negative infinity. Negative infinity is not a number, so it means it's a behavior that something, what? Does not exist, no? Okay? So, are there still not admitted? No more. Okay, so we now have, so that's what we mean by limit graphically, or the visual understanding of limit. Do you have any question, guys? Before we have specific functions and then get the limit from the graph? Because our approach is graphical first. Guys? Hi, guys. Any question? Do you hear me, guys?
Wala, sir.
Okay.
Wala po, sir.
Okay, so let's continue. So in other words, we want to know how f behaves near or close to x equals a. So that's our goal. What is our goal, guys? Yeah. Our goal is to examine, because this behavior is very important in calculus. There are so many physical phenomena or physical applications that behave like this, no? We want to know the value that is being approached. We want to know the limit, in other words. In physics, actually, it's very important. That is velocity, no? Velocity is actually a derivative, and that is the limit. Limiting what? Limiting position of, with respect to time. Rate of how fast the distance changes with time. Okay? So, that's a special limit derivative. So, our goal is to examine the behavior, to determine the behavior. This is our goal. To determine the behavior of f near what? Near a specific value of x. Near a particular value. A particular value of x. So that is at x equals a, no? Okay? So we want to know how f behaves near x equals a. Not necessarily at x equals a, no? But at least at x equals a. Okay? So better, of course, if the function is defined at a, so no problem with that. But actually our concern is on the problem. If there's no problem, so why do we have to solve that? No? Our concern is really on the function where the value is not the function is not defined there, and how the function is behaving near such number, no? So example number 1. So investigate 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 the behavior of f of x. I think somebody is joining. And our f of x is defined by x plus 2 near 2. Near x equals 2. Near 2. That's what we want to know. Near x equals 2. Graphically. I want it graphically. Because possible also to examine the behavior numerically later. You will see how. And then after, the numerical and the graphical will lead us to the definition, formal definition of limit. Let's check one that is entering. Yeah. That's number 1, no? Let's have this is number 1. Okay? Yeah. Let's get the function. Sorry. Oh, let's have that. Let's keep that there. I think it's hard to get that part. So first, let's draw the graph, no? So you should know how to draw the graph. That's why we studied function. No? So how do we draw the graph? So let's draw the graph so that we can examine the behavior. Okay. So this is our y-axis. And then our x-axis. So we have here. So let's say this is our x-axis. And I want to know how this function, the given function, behaves near x equals 2. Near x equals 2. So we have this graph. Let's draw the graph. At x equals 2, no problem, no? The function is defined. So actually, this is a nice function. That later, we'll not be talking much about this. When we deal with limit, our focus will be on those having problems. But just for the sake of illustrating, both those with no problem, with problem, so we discuss this thing like this. So when x is equal to 1, let's have 1. Let's have some values. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So this is 4. This is 1. This is negative 1, negative 2. And this is positive 2. And this is positive 4, positive 6. So let's take the point. When x is 0, so we have 2. What's the value? When x is 0, what's the value, by the way, guys? When x is 0, 2, no? Am I right? Oy, guys, you answer. So that I know if I have still talking to to u. So we have, when x is, what else? What value we can assign? Of course, when x is 2, so where we are interested, so but it so happens that the function is defined there, no? It is 3. Somewhere here. When x is 2, the point is somewhere here. Okay? So, next, when x is, let's say, 3. When x is 3, we have 5. When x is 2, 4. When x is 3, when x is 2, sorry, dapat, when x is 1, 3. Yan, 3. Di kasi kayo nasagot eh. When x is 2, 4. Somewhere here. Okay? Yan. And then, when x is 4, when x is 2, 4. When x is 3, 5. Mga narito yan natin. Somewhere. Dito. Okay? Yan. So, I can now trace the line. So, this is now the line. Yan. This is the line. The straight line. Hopefully, I will be able to trace it nicely. So that's the line, no? It's not a perfect one. Yan. It is the point where we are interested. It so happens that the function is defined there. Okay? So, my interest is on x equals 2. No? I want to travel along the line approaching to this value x equals 2 from the left and also from the right. So I will travel now. Huh? Travel. As I travel from the left along the line, so what do you notice? Where does the value of y go? Yeah. It seems that it goes to 4, no? What about from the right? Travel. I exceeded. Travel. So notice that from the right, it seems that it also goes to 4, no? So that behavior is described by what we call limit. And we write, mathematically, how do we write that behavior? Remember, we are just approaching 2. We are not evaluating the function at x equals 2. What is happening to the value of the function? It gets closer and closer from our figure. It seems to get closer and closer to 4. So mathematically, this behavior is what is written. So again, mathematically, we write this behavior. We write, yan. Although ako lang nagsusulat. I'm the only one writing. I will include you. We write this behavior. How do we write mathematically this behavior? Are you excited? This is how we write that behavior. F of x approaches what? 4. Yan. As x approaches 2. That is how we write it mathematically. Or equivalently, limit, yan, as x approaches 2, and that is both from the left and from the right. So that is what it means. So x approaches 2, meaning from the left and from the right, of f of x, and that is f of x is actually x plus 2, is equal to what? Is equal to 4. So that is how we write the behavior. Again, when I travel along this line from the left, going to x equals 2, but I'm not trying to really actually stop at exactly 2. I'm just trying to find the behavior. So going, approaching, from the right, going. What do you notice? The value of f of x approaches the number 4. And we call that limit. So this is how we write the behavior. Okay? And note here, we take note that it so happens that f of 2, it so happens but not all the time. So f of 2 happens to be what? Equal to 4. And that is also the limit. So meaning, there are possibilities that the limit is equal to the function value, like in the case like in the case of this, no? Yan. In this case, but not all the time, huh? Okay, so let's have another one. Another example, number 2. Investigate the behavior of f of x. Yan. Our f of x, let's say, is equal to what is a better function? Let me think. F of x, f of x, quotient. Let us have quotient. X squared minus 4. I think better x squared minus 4. And then x minus 2. And I want to know the behavior near what? Near x equals 2. No? So I want to get the behavior near x equals 2 graphically. Oh, let's have this. So again, let's draw the graph. Okay. So let's draw the graph. So solution. Now, f of x can be simplified. I can simplify the function, no? Because you notice that the numerator is factorable into what? Children of the Philippines. We can factor this into x plus 2. What else? X minus 2. No one is answering. Do not chat for your answer because I can see the chat box. Because I'm on full screen. What's happening, guys? What's now the simplified form? Guys, I can cancel this. But once you cancel that, it's not totally equivalent to the original. No? If you cancel, I will get x plus 2. Notice that x plus 2 has no problem for any x. But the original has a problem when x equals 2. So we write here, for x not equal to 2. Meaning, this original function is equivalent to x plus 2 as long your x is not equal to 2. Okay? Yan. So, they have the same graphs except that we have to remove the point where x equals 2. So, let's now draw the graph of the original, but we draw it from the new function that we derived. But of course, we have to exclude x equals 2. Huh? So, the graph looks like we have, it's also a straight line, right? It's also a straight line, which is actually same graph with the previous. So same graph with the previous. Same graph with the previous. I will just copy the graph of the previous. Toot toot. Somebody's entering. Welcome. Okay, so we have this. Let's say I have to count how many. Let's say 1, 2, 3, 4, 5, and then 6. This is y. Again, this is 4, 2. This is 4. Where is 4? Am I right? 2, 4, and this is 6. This is negative 1, negative 1, 2, 3, 4, 5, 6. This is x. When x is, again, 0, we have x equals 2. When x is 1, x equals 3. When x is 2, we have x equals 4. Pero, it's a whole. Yeah. Meaning, it's open. And then when x equals 3 equals 5. Okay? X is 3, we have 5. Yan, okay. So, let's now trace. This is 6, no? I will trace now the function. I have to make it straight. So I have to to graph it gradual so that it will really be straight. Yeah. So then I will now trace it. Wait. Okay. Okay now? So these are some of the points that we plotted. Again, this is a hole. Huh? So this point is a hole. Hole. That's the difference between the first function and the second function. Although the second function that we had, the graph is also a straight line, but there is a part in the straight line where it is open. So it's like it is a street where there is what? There is a crater or a hole, no? So that is a problem. So this is x equals 2. This is 4 and this is 6. This is where we are interested. No? So again, we want to travel along the line approaching this number. Approaching from the right, I travel. So travel. Oops, I'm going to reach this hole. So it seems that as I travel from the left along the line, I will approach this hole. Meaning what corresponding value? I am approaching, but that's not the value. I'm just approaching to the number 4. What about from the right? Travel. Oops, going also to this, no? To this hole. So notice that number 1 and number 2, they have the same behavior when it comes to values that are being approached by the function. They both approach to what? To 4 as x gets closer and closer to 2. Okay, but they are different functions, no? So mathematically, so again, how do we describe that mathematically? That behavior, mathematically, we write, I include you, ha? I'm supposed to write, I write, but I include you because I am indebted to you. We write this behavior as what? As, how do we write, children? So we have f of x approaches 4 as what? As x approaches 2. So, or equivalently, we have limit as x approaches 2, meaning that is both from the left and from the right. So f of x, what is my f of x this time? X squared minus 4, right? That is my f of x. Is equal to what? 4. Actually, later, once we write limit, this is how we write it. This is the commonly used notation to write the such behavior. So, that's it. So that's the behavior, no? That's what we get as in our investigation. Okay? Now notice here, we take note that function here is not defined when x equals 2. Okay? So it's not equal to where? It's not equal to the limit. As x approaches 2, they don't have the same values, no? Because the limit is equal to 4, while the function value is not equal to limit, therefore not equal to 4. This is actually undefined. That function value. But still, there is a limit. So that's the difference, no? So limit, it doesn't matter whether the function, what is defined there or undefined. What is important, the behavior that the function gets close, and the function values get closer and closer to that number 4, no? In that case. Okay, guys? Can you follow, children? Guys? Huh?
Yes, sir.
Okay. So let's now have. So far, limits here both exist now. So let's see. Both exist. Number 3, let's see if I have this number 3. This time my function is defined by this piecewise function. I want it to be piecewise. Piecewise. How do we write piecewise? I want it piecewise. What is a nice piecewise? Let me think. Let's say 4. And I want it when x is equal to greater than 2. When x is greater than 2. So as much as possible, I do not want to get out of the 2. So that you can see the difference. No? So it's still approaching 2. Then this is 2x. Let's say 2x. If x is less than 2, less than 2. And I want to know the behavior near what? Near x equals 2. Notice that here, x equals 2 is not in the domain. No? So also here, x equals 2 is not in the domain. But let's see if the limit will exist in this case. Okay? Again, 2 is not in the domain, but we want to know how f behaves near that number. Okay? So again, this is a piecewise. 1 is a constant function. 4 is horizontal line. F of x equals 4. Is horizontal line, no? Horizontal. Do you still recall that? Horizontal line. What about f of x equals 2x? Huh? Guys? Oy, guys. What can you say about y equals 2x? Huh? Y equals 2x? What is that? This is slant line, no? But of course, we want it to be less than 2, while the horizontal greater than 2. Let's draw the graph. Remember the given equations defining the function. Huh? There are 2 equations defining the functions at different domains. No? Subintervals, subdomains. So, how does the graph look like? So, let's see. Will this be enough? Let me have this, yan. And then, okay. So this is x, and this is, I think I need to make it smaller. Yan. Okay. This is x, y. So 1, 2, 3, 4. 1, 2, 3, 4. Then 5, 6, 7. So 1, 2, 3, 4. 5, 6, 7. Negative 1, negative 2, negative 2, positive 2, positive 5, 7. This is 2, this is 4, this is 4, this is 5. No? Let me have it 4 here. This is 2, 3, 4, 5, 6. So 6, yeah. So now, let's start to draw the graph. Horizontal line. So when x is greater than 2, so meaning we don't include what? We don't include the endpoint. So this is the horizontal line when x is greater than 2. So I am going to have hole here. There is a hole there. Yeah, there is a hole. And then when y equals 2x, so meaning less than 2 naman, we have less than 2. So when x is 2, 2 times 2, 4, but still not included, no? So open. When x is 2, 2 times 2, 4, but open. When x is 1, we have 2 times 1, 2. So somewhere here. So this is the graph. Let's draw the graph. Dun, 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 dun. When x is 0, 2 times 0, 0. So as long as less than 2. When x is 1, negative 1. When x is negative 2. When x is negative 1, negative 2, somewhere here. So here, there. Okay? So that's the graph. But of course, open here. Open at that point. So, sorry. I intentionally deleted it. What's happening? Okay, yan. I haven't activated the pen. So here, yan. And let's have some points. There are infinitely many points there, of course. Yeah. So I want to travel along these lines, these two lines, no, connected, but actually not really connected, no, but there is a separation, a hole. So this is hole. So I will travel again there. So from the left, travel, close to 2 from the left. So I will reach this. No, possibly I can what? I will be trapped here, no? I will fall there. So as x goes to 2 from the left, so it seems to go to 4, no? It seems to go to 4. So from the right, travel. Still I am approaching this hole. So as I travel from the right, I will approach again what value of y? 4 also. So how do we write that mathematically? That behavior, children? Mathematically, we write as what? As f of x approaches what? 4. As what? As x approaches positive 2. Okay, so or equivalently, we have limit as x approaches 2, both from the left and right. We mean that's what we mean by this x approaches 2, both from the left and right. So we have, okay. Now, by the way, since they are different functions, so I can separate this. Approaching equals 4, no? Or specifically, this is how we write, no? Specifically, we have limit, let's have f of x approaches 4 as x approaches what? As x approaches 2 from the left. Yeah. Because there are two different functions. F is defined by a different function. And this is equivalent limit as x approaches 2 of f of x, and actually that f of x is 2x, no? Is equal to 4. But I have to put negative on top of 2. So it means x approaches 2 from the left. And also, the behavior f of x approaches 4 as x approaches 2 from the right. How do we write that? From the right. With superscript 2. So, sa 2, no? I mean, with superscript positive, I mean. So, equivalently, limit as x approaches 2 from the right of f of x is equal to 4. So, since they are both equal, we conclude that the limit exists, and that's why, so, itong reason, ayan, this is the reason, these two, why we say that fx limit is 4, no? of f of x is equal to 4. So let's say I get here a different limit. From the left, let's say I get 4. From the right, I get 0. So our conclusion is limit does not exist. So since both from the left and from the right, they have the same behavior, even the function is defined by two different function equations at two subdomains, so still we get the same limit. So we say that the limit as x approaches to of f of x exists and it is equal to 4. Okay? Do you have any question, guys, so far?
None, sir.
Again, since the behaviors of f are the same from both directions, that is from the left and right of 2, we say that the limit exists, and collectively or mathematically we collect these two behaviors as one behavior. Limit of f of x as x approaches to is equal to 4. So that you are not going to write anymore 2 with superscript negative, 2 with superscript positive. So we can do that if you have the same what? Behavior. But if different behaviors, you cannot collectively write as a single limit. Okay? Yan. What about this? So let's have another one. Let's see if we can get something nice in this next one. This is number 4. Number 4. Investigate the behavior of this function. Again, piecewise. Yan, piecewise. 5. So far, the limit that we are getting, they exist, no? 1/2. Let's have 1/2 x squared. This is parabola. This is if x is greater than 2. If x is greater than 2, I want when x. And this is when x is less than or equal to 2. Or equal to 2. Near x is equal to 2. Notice that x is defined when x is 2, no? Because f of x is defined, f is defined. So when x is 2, because when x is 2, we have this equation. So let's draw the graph. How does the graph look like? So one is a constant function, the other one is not, no? So let's have here. It's not nice line. It's hard to draw a straight line. If it's ordinary board, I'm very good in sketching. I can sketch is using straight path. Yeah, let's have this. One more. I think it's I want it at the middle. So that is x. This is y, no? So 1, how many? 5, oh? You have 5. Why did I make it 5? So can I have it just 4 so that it will not be far? Let's change the problem. I do not, because it's too far. Well, let's have just 4. I do not know if there is a purpose. Y is 5. So let's have it 4. Para the graph is not too high. 1, 2, 3. Let's have 1, 2, 3, 4. Yan. 4 here. Okay, can I make it lower? Lower. Let's have it lower. Para it will not be difficult for me to draw. O yan. 1, 2, 3, 4. So this is 4. And this is 1, no? This is 2. Okay, let's now start. Let's draw first the constant part, no? Y equals 3. So when y equals 3, we have, do we include x equals 2? No. So it's open there. When x is greater than 2, so we don't have yet 2. 1, 2, 3, 4, 5, yan. This is 2, this is 4, this is 5. Negative 1, yan, negative 1. So we have, this is negative 1 also. So let's have, when x is 2, so, but this is open, no? We have horizontal line. When x is 2, y is 3, or the function is equal to 3. As long as greater than 2, no? When x is 2, but it is a whole at that exact 2, no? So it's a whole new world. Yan, it's open there. What about less than 2? When x is less than 2, we have what? Less than 2. Let's start with 2. When x is 2, 2 squared 4 divided by 2 is 2. Oh, it's here, not there anymore. It's here. When x is 2, the value of y is 2. Okay, guys? What about when x is 0? So it's 0 here. Parabola yan. When x is 1, 1 half. 1 half. When x is 1, 1 half. Let's now draw the parabola. Okay, parabola. Oh, yan, parabola. Travel. Later, I will be traveling there. Travel. Yan. You know the importance of having a function that has no problem, guys. When you, let's say, you involved in a company trying to have mathematical modeling, you always try to come up with a function that will not encounter any problem. But there are mathematical formulations that you cannot avoid. We will encounter a problem, but how to deal with? That's why we study in math thing like this, no? Yeah. Okay? But of course, this is not up to this only, no? Less than, it can be continuing like this. Yeah. But we are not interested anymore here. We are interested with this part only. Okay, so let's now travel again. Guys, are you still alive? Huh? Are you expecting that the calculus is like this? So don't worry. Once we were done with this, you will say better to go back here than having mathematical procedures of finding limits, but it's hard to find the limits. But if you can only have a graph, you can find the limit easier. No? But it's not always easy to draw graph, no? Unless you use software. So again, from the left of 2, or travel. Oh guys, question, where do you think the value of the function go? Huh? Guys, where do you think? As I travel from the left, along this parabola, travel, going to the right, meaning approaching 2. So where does the function go? They are not answering. I'm talking to mute people. So mathematically, we say that. So this is the behavior. Mathematically, how do we say that behavior? Mathematically, yeah. Mathematically, because it is from the left, mathematically we say that we write, because there are different actually equations, no? So we write as limit. Yan. I'm not going to write any more this notation, since we are already familiar with this thing. So limit as x approaches what? 2 from the left. Of f of x. What's the answer, children? From the left? Guys, what's the limit from the left? Anyone? Guys, do I have to call a name? What's the limit? Do not chat because I can see the chat. Car Matthew. Borinaga, Villarojas, Bartolo, any one of you? What do you think? As I travel from along this parabola from the left,
Sir, 2.
it seems to approach 2, no? So the limit, we say that the limit is 2. That's how the function behaves. But the value of the function does not mean equals 2. Although it so happens that the value of the function there is 2 also. Pero what we are interested is just the behavior and the limit only. Okay? Now what about from the right? From the right naman, from the right. Travel. It seems to go to this hole. What's the value? As I travel from the right, travel, the value of y goes where? Saan pupunta ang value ng y? So it keeps on what? It is actually fixed, no? Going to this value. It does not come from the top actually, no? Actually, this one, it does not really come from the top. Specifically, this, it comes from where? From above, no? From above. Not really from above. From the horizontal. So as I travel, it is always 4. So as I travel, it is always 4 going to this value. What value is that, children? Guys, kanina I think I heard someone who has a good mic. She has a good mic, no? Limit. How do we write that? As x approaches 2 from the right of f of x. So what is the answer, guys? Guys? Anyone? Guys?
Sir, 3.
3. What can you say this time? The two behaviors are different, no? But we want the behavior of f to be the same from both directions, from the left and from the right. But we came up with two behaviors that are different. One coming from the left, we got 2. Coming from the right, we got a value that is approached by the function which is equal to 3. So the limit from the left 2, the limit from the right 3, as x gets closer and closer to 2 from the left and from the right respectively. So we say that collectively, pag kinolect natin yan, collectively as x approaches 2, both from the left and from the right of f of x, the limit does not exist. Does not exist. Yan. Do not put equal, ha? Yan. So again, we conclude that, so therefore, our conclusion, the limit of f of x as x approaches to does not exist. By the way, does not exist, we denote it by D and E. D and E. So that is our agreement. Again, how are we going to denote our phrase does not exist? D and E. So we mean D and E. Or we write like this, or limit as x approaches to of f of x does not exist. Yan. Do not put equal, ha? No, if you put equal, wrong. Do not put equal, ha? Because f of x, this is not number, no, that you are supposed to equal. And aside from that, it does not sum limit of f of x as x approaches to equals does not exist. It's not a good English, no? So no equal. Just like this. Is that clear, guys? Hopefully it's clear. Let's move. Okay? So again, remark, caution. I will put here as caution. Caution. Red alert. Although it is orange alert. Caution. So that you are reminded. And once you do this, let's say you do this, instead of just 0, negative your score. Negative. Instead of just 0, let's say you got mistake, your answer does not exist, but you put equal. So instead of just 0, I will just make it 0. I will make it negative the score. Because for you to what? To remember it the entire of your life. No? Caution. So limit, yan, limit. As x approaches, let's say, 2, yan, of f of x, and you put equal, equals does not exist. So that's not correct, no? That's not Correct. Yan. I will put big mark. Yan. Okay? Yan. It's not right to write. Okay? Ayan. Is that clear, guys? It's always head and shoulder. It's not clear. It's a head and shoulder, I think. So let's have the last graphical example. So this is the last, I think. So that we can proceed later to numerical. How do we do it numerically? How to investigate the behavior of the function near a certain number numerically. On number, so in that case, notice again that the function is what? Does not exist, no? But by the way, what can you say about the value of the function here? What can you say about the value of the function? The value of the function at x equals 2 is defined, no? F of 2 is equal to what? Is equal to 2. So which is equal to the limit as x approaches 2 from the right or from the left. From the left, no? Of f of x is equal to 2. Pero not equal saan? Sa limit from the what? From the right, no? Not equal sa limit from the right. Yan. So they don't have the same value. Let's move this a little to the right. Control X. I'll try to move this so that it's nice. Let me move it here. Yeah. Okay. And then I'll try to move this here. There. Okay. And then try to again change this to, let me change this to Y. Is it possible for me to change this to Y? Let me check. Y. Yeah, there. Okay. So let's now have number 5. This is number 5. Number 5. Limit. Yan. As. Sorry. So we have what's the function? What's a nice function? F of x is equal. I want to have something having asymptote. 1 over x or 1 over x plus 1. And 1 over x plus 1. Near x equals negative 1. So the function has a problem here, right? No? Because at x equals negative 1, we have undefined value. So, solution. This function has a vertical asymptote. It has a vertical asymptote. So, f has a vertical asymptote where, as what you had in your Gen Math. If you had your Gen Math, you had this. No? Vertical asymptote at x equals negative 1. So, let's draw. So, we have negative 1. Let's have it here. Y. And then, let me move this down. And then here we have yan, x. And then we have a vertical asymptote. Let's have this vertical asymptote when x equals 1. Yan. So it is a number, a line, approached by the curve, but it will not touch that. It will just get closer and closer. This is how the function behaves. By the way, let's get some points. No? When x is 1, let me have a value. When x is 1, 1/2. Let's say this is 1/2. When x is 0, we have 1. We have a point here. When x is, let's say, 1/2, 1/2 plus 1 is 3/2. So you will get something 3/2, 2/3, something like that, na? So again, a 3/2, what is that? When x is negative, when x is negative 1/2, when x is negative 1/2, plus 1, that is 1/2, so equals 2. So 2. So somewhere here. Yeah. So this is now the graph. Let's emphasize those some points that we had. Actually, it is also asymptotic to the x-axis, I think. It is asymptotic to the x-axis. Because because the numerator is constant over a varying number, it cannot be 0. No? When you have a constant other than 0, not 0 constant in the numerator, whatever value you put in the denominator, you will never get 0 value for y. So asymptotic to x-axis. Okay, so let's now draw. Ayan, asymptotic. Let's try to draw a curve. Yan. Actually, it's like I am already traveling, no? Yan. So what about here? So just reflect those values that we had. We had when you have closer, when we have negative, what value? Kapag negative here, negative, so somewhere here, negative 2. The point is here, we have negative 2. I think the point is here. Yan, if you have a point here. If I have a point here, it will be at 1, I think, at 1. If you have a point here, a 1 here, a 1 here, a 1 here, I have 1/2, I think, negative, something like this, no? Yan. So that's how leaving or entering, there is still one joining. So let's now draw. That's how the graph looks like. Yan. Okay. So let me trace it well. Yan. So that's the graph. Then, let me emphasize some of those that I considered points, no? And so, this is 1. We are interested with what? With x equals negative 1. This is 1. This is x equals, this is x equals negative 1. Where will I write that? I can't draw this one. This is x equals negative 1. Yeah, negative 1. Okay? Let me write it clearly. x equals negative 1. Yan. That line. Okay? So, again, from the left, let's write mathematically the behavior. Mathematically, yan, mathematically, we write, once we finish this introduction, we are now fast because all computations, and you won't like it for sure. Many don't like computations in calculus. I think you heard what calculus is, no? You heard how tyrant is calculus. Calculus is not friendly. There are so many lives destroyed by calculus. Even family. Calculus, calculus is evil. We don't like calculus because sometimes it destroys families' relationship. Okay? But I don't know why we have to study really this, no? Because if you want to be engineering and understand things in engineering, mathematically, you really have to make calculus. Because most of the derivations make use of calculus. Many things changing. So travel. From the left, travel, approaching negative 1. Travel. Oh, what is happening? So we write. And we write as f of a, as x approaches negative 1, where does the function value go? It goes down and down, meaning it keeps on getting negative. So it means f of x approaches negative infinity. As x approaches what? As x approaches negative 1. Yan. Okay? Oh, yan. Again, travel. It goes down. It keeps on decreasing. Or, equivalently, we write, yan. How do we write equivalently? As x approaches from the left, x approaches negative 1 from the left. From the left. Yan. So, we write limit. Yan. As x approaches from the left, negative 1 from the left, of f of x, it is equal to negative infinity. It's all right to write negative, meaning because that is limit. Limit and the behavior meaning getting bigger and bigger negatively. Okay. Equals infinity, negative infinity. It sounds good in English. No? Unlike limit of f of x equals does not exist. Or it doesn't sound good. And also, let's have from the right, travel. Oh, what's happening? Guys, f of x is what? Approaches positive infinity. It keeps on growing. As I go to x equals 1, negative 1, traveling from the right along the curve, it keeps me going up. So, as x, what? As x goes to the left, goes to negative 1 from the right. Yan. Or, equivalently, we write what? Limit as x approaches negative 1 from the right of f of x is equal to positive infinity. Okay? So, how do we write this collectively? No? So, collectively, we say that since f of x does not approach a definite number from either side of negative 1, the different behaviors are attained by f from the left and from the right of negative 1. No? So, we simply say that, so, the behavior now is what? The behavior is given by f of x approaches no limit. F of x does not approach a limit. So approaches no limit. Okay? As x approaches negative 1. Or equivalently, equivalently, how do we write that equivalently? We say that limit, meaning we write these two behaviors as x approaches -1 of f of x does not exist. Okay? Again, the limit of f of x as x approaches -1 does not exist. Actually, it is enough to determine one side only to know whether the limit does not exist. But if you want to have the specific behavior, this is how you do it. Okay? So, for the limit to exist, both from the left and the right must exist, meaning both are real numbers and are equal. Not just real numbers, they are equal for the limit to exist. Is that clear, guys? Any question, guys? Huh? Any question, guys?
Wala na po.
Note here also that f of -1 is undefined. Is undefined. Na? The function value is also undefined there. Aside from being undefined, the limit does not exist. So this function is not nice. Okay? But this is better for those two people who are fighting because there is no connection between them. A very nice separation. But for those having good relationship, this is not nice picture. Get it, guys? Now, the value of f at -1, as you know, this is not defined. Okay? So, but the limit behavior of f has nothing to do with this. It has no bearing on the existence or non-existence of f of -1. Again, the limit behavior of f has no bearing on the non-existence of f of -1. Kung hindi man nag-exist ang limit, walang pakialam yun kung bakit naging undefined ang -1, ha? So, it's a different story. Okay? Also, it is important to realize that the existence or non-existence of the function value at x equals a has nothing to do with the existence of the limit of f of x as x approaches a. Ha? So, remember that. Now, notice that we have here infinite limits, no? Meaning the limit is getting bigger and bigger without end, either negative infinity or positive infinity. Now, we summarize this behavior as follows. So, we summarize. These infinite limits, meaning the limits are infinite limits. And infinite limits mean do not exist, ha? Infinite limits. As follows, yan. As follows. So, how to write properly the limit which is infinity, for instance, infinite limits. Let's say I have number 1. If I have limit as x approaches a from the left, and it so happens that it is positive infinity, and the limit of as x approaches a from the right of f of x is equal to positive infinity also, we can simply write this. This is equivalent to this end equivalent to limit as x approaches a of f of x. You can, since they have the same behavior, both positive, although they both do not exist, no, as limits, but we can write it as positive infinity. These two collectively, I can simply write, if you have from the left, from the right, same behavior, I can simply write like this. If I have two limits from the left and from the right, with both signs the same, negative infinity, I can also write that as what? Yan, as one behavior. And limit as x approaches a from the right of f of x, and it so happens that it is also negative infinity, so we can write equivalently this behavior as just one limit of f of x equals what, children? Negative infinity. Okay, very good. What if they have opposite signs? Yan. If they have opposite signs, let's say limit as x approaches a from the left of f of x, yan. And then the other one equals, let's say, negative infinity, and limit as x approaches a from the right of f of x, one is positive infinity. Collectively, we just write this as what? How do we write this collectively? As x approaches a of f of x, we cannot write it as infinity, but we just write does not exist collectively. If you want to write both as one, because they don't have same behavior. But actually, all of this do not exist. Like for instance, I can write this positive infinity means also that it does not exist, but specifically it gets bigger and bigger, because does not exist means not only positive infinity or negative infinity or having the same behavior, negative infinity, same behavior, negative positive, but also if you have limit from the left exists, limit from the right exists, but not equal, it still does not exist. The limit collectively. So, does not exist is something that does not mean for infinity only. Huh? It also means for limit from the left, limit from the right, having the same, having no same limit. Yeah. So again, remember that these limits don't exist, all of them. The infinity symbols, negative infinity and positive infinity, are used to indicate, used here indicate only the specific behaviors of limits which increase negatively or positively without bound, respectively. That ends for the graphical. Do you now understand what limit is, children? When it is going to exist, when it is not going to not to exist, huh? So you have now the picture. So that's what we mean by limit. It's not the actual value. It's of the function. It is just the behavior. The function may be defined there, may be not defined, but possible for the limit to exist. The next approach that we're going to have, numerical approach. So this time, numerical approach. Numerical. Numerical approach. Of limit of a function. Yan. Okay? So again, another way to introduce the concept of limit of a function is by investigating the values of f of x near x equals a numerically. Now suppose we have the following functions examined near x equals a as in the following. Number 1. So this time we are going to investigate. Investigate. I will just give you 2 examples. So at least, because I know you understood already from graphical, I just want to just let you know how to investigate numerically. Investigate or examine. Investigate the behavior. The behavior of f of x, f of x, which is equal to x squared, x squared plus 2x minus 3 all over x minus 1 near, parang kanta lang yan, near, far, but we want near x equals a. Will it get far or will it be going to a number? pag near x equals 1, the function gets far, or meaning it's going to be positive infinity or negative infinity. Yun. So, near, far. Numerically. Yan. This is letter A. Let us separate na. Let me write again. Of letter A, number 1. The subnumbering. Investigate the behavior of number 1. F of x equals is x squared plus 2x, no? Plus 2x minus 3 all over x minus 1 near x equals 1. Notice that the function has a problem at x equals 1. It is not defined there. But let us see how the function behaves as its x values get closer and closer to 1. So, we are going to prepare a table of values. So, solution, prepare a table of values. Prepare a table of values as follows. Yan. So, we have this. I think I will need much space. Okay. I need ruler for this case. I think I will be needing how many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9. Mga 10 columns, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up to this. Mga 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up to this, yan. 2 values. Will this be enough? Okay. Yan. Okay. Yan. And then, I have another here. Okay. So, we have, and then, I'll be copying this table for the next problem so that I'm not going to make one anymore. We have this. I think I can have two immediately. Yan. And then, yan. And then, oh, it moved. Why did it move? I didn't expect it to move. Bad ruler. And then the last, I think, we have here. And here we go. We have this table. Okay? Yan. I'm going to copy this later because I will be needing this table. Lasso, copy, and then put it on the next, and here. Because I think I will be needing that later. So we can save time. So this is x value. We have here f of x. So I'm going to have from the left. So here, I want your x to approach. X approaches what? Approaches, yan, approaches what value? 1. Approaches 1 from what? From the left. From the left. So that's what we mean. From the left. Okay? So 1, 2, 3, 4, 5. And then here, approaching, yan, approaching, x approaches. Well, on the other side, x approaches, and x approaches 1 from the right. From the right. Yan. So from the left, we assign values. Close to 1, but less than 1, I mean. Close sa 1, but greater, less than 1. Kasi from the left. Enough na close. So meaning, do not exceed anymore x equals 2. Because 2 is not really close to 1. So let's say 0.9. I can start with 0.9. Then I can have 0.99. Then I can have 3 nines, 0.999. I can have 4.9999. Okay? Yan. And then, this is at x equals 1, but this is where we approach, no? X approaches to this. And then, we have, from the right, we can start with 1.1. Greater than 1, but close to 1. 1.01. 1.001. And then finally, we have 1.0001. You can assign arbitrary values that are small. Greater than 1, less than 1. From the left, less than 1. From the right, greater than. And let's see how the values of the functions behave. No? If I assign 0.9, so substitute here. Now, you will get a value. By the way, we can simplify this. No? F of x can be written, when factored, I can factor that into x minus 1, x plus 3, all over, yan, x minus 1. So I can write this as, what? X plus 3, as long as x is not equal to 1, no? So meaning, it's easier to compute the value sa x plus 3 rather than in this quotient. After all, what we are assigning not equal to 1. What we are assigning, where's my calculator, is less than 1. So 0.9 plus 3. What value do I get? 3.9. 3.9. So 0.99 plus 3. What do I get? 3.99. 0.999 plus 3, I will get 3.999. Okay? So meaning, if I substitute here, 0.999 squared plus 2 times 0.999 minus 3 all over 0.999 minus 1, I will get also 3.999. And then if I have 0.9999, I will get 3.9999. So it means what values seem to approach by the function. So that's a question mark. Let's see from the right. What value? 4.1. If I assign 1.1 plus 3, this is 4.01. This is 4.001. This is 4.001. Notice that both from the left and from the right, as x approaches to this value, x equals 1, yan, approaches to this value, approaches to this value, yan, approaching, yan, approaching, where do you think the function value approach? Again, where do you think the function values approach? Approached, guys. Huh? Guys, it's approaching to 4. So, that is our conjecture. No? So, our conjecture is that the limit, so our conjecture, we conjecture, so we conjecture means we are having a wise guess, a wise decision, conjecture, that limit as x approaches what? Approaches 1, both from the left and from the right, as you notice, of f of x, it is equal to what? 4. And that is how we write it. Okay? So, yan. So, that is using numerical investigation. Let's have last one for the numerical investigation. That's how to investigate the limit. But of course, there are limits that once you investigate like this, numerically, you don't get something that is specific behavior. So, something tricky. No, you will encounter a problem like that. And you need mathematical procedure of finding the limit. So, it's not always the case that investigation like this will give you accurate limit. I tell you. Okay? Let's have the second one. Number 2. So, we have number 2 now. Our function is, let's have, involving trigonometric, f of x equals sine x over x. Yan. We assume that x here is a real number. So what real number corresponds to degrees? Radian measure, no? So in radian measure. I want near x equals 0. No? So investigate numerically the behavior. Did I write numerically in the previous one? Near x equals 1 numerically. So that's why we have no choice but to do this. No? Okay? Note here, by the way, note here that f of 2 is f of 1 is not defined, is undefined. So, yan. So, again, we prepare a table of values. So, construct or prepare a table of values both from the left and from the right of 0. Take note that, again, we assign real values, radian measures of x. No? So, how many? 1, 2, 3, 4. Let's have 4 values also. So, this 1, 2, 3, 4. This is the middle. So, this is where the x is approaching, no? The values of x approach. And we want to know this, no? This is what we want to know. X, y, f of x. Again, your x approaches 0 from the left. Here, your x approaches 0 from the right. Okay? Approaches 0 from the right. So, we want to know, yan. Wow. We want to know here. I want to know the. So, from the left, from the right. So, better to assign, I think, let's start with x is negative 1 from the left. Then I will get point what? If you use calculator, sine sine negative 1, radian measure ha. Be sure your calculator is set to radian mode. Sine of negative 1 over negative 1, this is what I got in my calculator. I got something positive. Did you get positive number, guys? Huh? So I get, could you try number? I'm reading from the 8, 4, lilit naman ang sulat sa calculator, 1, 5. So this is what I got. When x is negative 0.5, sine of negative 0.5, sine of negative 0.5 in radian mode divided by negative 0.5. So this is what I got. 0.9589. When x is negative 0.01, I mean 0.1, let's have 0.1. So I have sine 0.1, negative 0.1, I get 0.9983. What about if I have negative 0.01, which is, I think, enough to be close to 0, no? Or 0.001 if you want. So 0.01 negative. I get 0.9999999. What do you think the behavior, no? So, what behavior do you think? From the left, you notice that f seems to approach what? Seems to approach? Approaching 1, huh? Let's see what happens to f of x kapag from the right, start here. Let's start with 1. I get a value that is 0.8415 also. Oh, so I can see a pattern. 0.5. Oh, I get also same value. 0.9589. So I will just copy the value. Although I will make the x values positive. 0.1, 0.01. So here I get 0.9983. While here, 0.9999. So what do you think? F of x approaches 1 also. So we now, what? Have this conjecture. So let me transfer because we have too much space. Let me move you here. Move you here. There you go. Yan. So our conjecture, we now, we conjecture, what do we conjecture, guys? Or we infer, if you want to use the word infer. We infer, if you do not want to use conjecture, we infer that what? That the ratio sine x over x, that take note x is in radian measure, or that is a real number, approaches what? Approaches 1 as x approaches 0, both from the left and from the right. Okay? And we write, how do we write that in formal notation? Limit, limit. And you have to remember this because this later will become a formula in what? In finding the limit involving trigonometric function and a polynomial, an algebraic expression like say x of sine x over x is equal to 1. Yan. So, okay? Did you understand, guys? That is how to find by numerical value. Okay? Now, if your behavior from the left, from the right, very clear that they do not approach same value. So, perhaps you can infer that the limit does not exist. Let's say a behavior, 0.9999, 0.999, approaching 1, but the other one, 2.9, 2.999, 2.9999 from the other side. So it is clear that the limit being approached by the function is not unique from the left and from the right. Therefore, you can say that the limit does not exist. Okay, guys? Still alive? Huh? Oh. Guys?
Yes po.
Okay, so let's have the last one. Last one. This, I will copy this, this table. So, last four, I will copy this table because I do not want to prepare the table. Copy in the next slide. Yan, there. But I have to erase values, no? Erase. I have to make medium eraser. I do not have to erase that. So here, clear. No. Here I was. I have to make it, I think, the smaller one. Because others are affected, no? Yan. I have to and then this. I can't erase also. I thought I couldn't erase. Yan. So it's now clear. Because it's not easy to prepare table. Okay guys, ha? I am assuming you are following, ha? You can follow. Okay, so let's have this last number. I will just give you by numerical, not existing the limit. Let's say our f of x is equal to something 1 over x minus 3 quantity squared. Be ready with your calculus so that you can do together with me. Numerically. Yan. So, solution. So, first thing that you have to do, construct table, of course, no? Construct, yan, a table of values. Values as follows. So, approaching 3. So, this is the middle. I want it to be going to 3. So, this is my x. But, of course, the function value is undefined there, no? So, what is the behavior? Okay, I know that there is no exact value, but what about the behavior? Where does f of x go? Where does f of x go, no? What about here? From the... So, x approaches where? From the left. X approaches where? From the right. So, okay? So, let's see. What value am I going to assign? Let me start with 2.9. 2.999. Ayan. These are my values that I'm going to assign. 9999. And the last one, 0.2.999. I think this is enough to be close to 3, no? So, this is 3.1, 3.01, 3.001, 0001. Yan. Enough, no? So, what value? I use calculator. 2.9 divided by 1 over 2.9 minus 3 quantity squared. I get what? Again,
100.
100. 10 squared, no? 10 squared, 100. So, let's have powers. What about 2.99 divided by x minus 3 quantity squared? I think it is 10 to the 4th. 10 to the 4th in my calculator. Okay? What is 10 to the 4th? 10,000, no? What do you notice? If you have 2.999, 10 to the 6. So imagine 10 to the 6. But what do you notice? 2.9999, 10 to the 8. It's getting what? It's getting what? What do you think? What do you expect if you have 2.99999? You will get 10 to the 10. Or what's going on? Oh. Okay guys, bring it on. Bring on the value approached by the function. So according to Mr. Gumabo, bring it on. But she lost the Miss Universe Philippines pageant. Okay guys, what to bring on? Guys, what do you think? Where does the value go to? It keeps on what? What do you notice? It keeps on getting bigger and bigger. What does it mean? Positive infinity. Yes. No? What about from the right? From the right, we have 10 squared, 100 also. You will get the same 10 to the 4. So we have 10 to the 6, 10 to the 8. So same behavior. So again, positive infinity. Okay? So we denote this behavior. Yan. We denote this behavior. This behavior as what? As, yan. From the left, we have limit. As x approaches 3 from the left of f of x, what do we get? Negative positive infinity. And from the right, we still get the same, no? We get from the right, the limit of f of x, we have also positive infinity. So, okay? Now, we can collectively write, and this is equivalent, these two, we have limit, yan, as x approaches 3 of f of x to be simply, in our summary, positive infinity, positive infinity, positive infinity. Okay, guys? Guys, I think there is going to have a new typhoon. And according to the news that I got here, is stronger than Rolly. What's happening to the world? So I think the heaven is trying to eliminate number of people here on earth, no? So again, more powerful than Typhoon Rolly. So what does it mean? We will have another vacation? My goodness, a lot of vacation. Okay? But of course, we have to pray for the people who will be affected. Hopefully, it will not fall, no? So it will go to Antarctica. After all, in Antarctica, I think no people there, no, just scientists. Okay, guys. Yan. So that's or we write, if you want, you can write here the specific function. You write the specific function. Ay, what's happening? I can't erase. You write the specific function. What is our f of x, guys? Ano yung f of x natin? You can have it if you want 1 over x minus 3 quantity squared equals positive infinity. It's alright if you write just infinity, ha? Positive infinity or infinity, just the same. Okay? I'm just used to you to write positive infinity. A question, guys? No more question, huh? Okay, guys. I'm assuming you are understanding it. Okay. Yan. So, we're done. So, later you will be having mga activity about this. Okay? So, we now move to informal definition of limit. Okay? Again, we now move to informal definition of limit. And then later, formal definition. So, from those behaviors that we got, so analyzing the functions near specific values, so obtaining limits, either real number, non-real number, meaning limit exists and possible also for the limit not to exist. So we now have the following definition. So definition of limit. Definition. of limit. Oh. So how do we define now limit of a function? Or how do you define from the behaviors that we have? So how do we define? So again, we observe how a function f behaved near a specific value of x. The different observations, graphical and numerical, for the behaviors of f near x equals a lead us to the following intuitive definition or of limit of a function. When you say intuitive, that is a wise guess, no? So based on our intuition. So this is how do we define it. So limit of a function. Definition of limit of a function. Yan. This is informal definition. So informal, I will write informal. Informal or intuitive. Intuitive. Paano ba intuitive? Intuitive or informal. Yan. Informal. Yan. Meaning, this is not really the mathematical definition. This is just by intuition. Informal definition. Okay? Definition. Okay, so how do we define limit of a function? By intuitive or informal definition. This is how. To define a limit of a function, of course, we need a function f. So, if, let's say, if the values of f of x, if the values of f of x, as what we observe, no, can be made, if you can make the values of x, f of x, as close as we like, yan, as close as we like, yan, as close as we like to the number, to a certain number, to the number, let's say the number is L, that is a real number, by taking, how are we going to make the function values to be close and close to L? By taking the values of x, so you have to take the values of x. So in order for f of x to be close and close to the number L, you have to make what? You have to make the values of x sufficiently close to A. Sufficiently enough. Sufficiently close to A. The problem in intuitive definition is that how close, no? How do we say that the number is really close, no? That's why later we need to mean what that close, sufficiently close means, no? Sufficiently close, because we cannot really measure how close, no? How sufficiently close the numbers are to A, sufficiently close to A, to A. But not equal, of course, but not necessarily equal to, But what we do not want A to be actually equal to what? To, but not equal, but not equal to A. We want only to approach the value to A, equal to A. So that's what we want. Then we say that, we say that the limit, I will make it color orange, that the limit of f of x, that the limit that I will have just here, that the let us have that the sorry, this is supposed to be white and this is the orange, that the limit of f of x as as x approaches a is what? Approaches, let me make a beautiful. A, because this is not just an ordinary letter, but we mean variable a. I mean constant a. Is what? Is L. Okay, so that's what we mean by making the values of f of x close to what? To L, by taking what? The values of x sufficiently close to A. So again, if you can make the values of f of x close as we please or as we like to L, by taking the values of x sufficiently close to A but not equal to A, then we say that the limit of f of x as x approaches A is L. And we write, yeah, and we write, and we write f of x approaches L as x approaches A, or equivalently, so how do we write that equivalently? Let me have it a little bit bolder. Limit, yan, as x approaches A. So if you have x approaches A, meaning it both understood both from the left and the right, of f of x, yan, is equal to what? To L. Okay? A, of course, and L are supposed to be real numbers. If the limit does not exist, of course, it's not L. It is either negative infinity, positive infinity, or possible does not exist only. Because the limit from the left, limit from the right, although they both exist, but not equal. Okay? So that is how we define limit of a function intuitively, or in the informal way of defining the limit. Any question, guys? With the definition, you memorize the definition. If you can make the values of f of x as close as we please to the number L by taking the values of x sufficiently close to A but not equal to A, then we say that there is a limit, and the limit of f of x as x approaches A is L, and that is how we write it. Okay? Lim of f of x as x approaches A is equal to L. Let us have some exercises. Yan. Exercises. So, another example. For the given graph of the function, let's say you will be given graph. For the given graph, I will write it fast. For the given graph of the function f, I will make a graph. Determine the limit, if it exists, the limit if it exists. If the limit does not exist, if the limit does not exist, indicate whether positive infinity or negative infinity. Or negative infinity. If possible, if possible. If you can write it, just one symbol, negative infinity or positive infinity, if possible. Or simply, kung hindi, does not exist. D-N-E. Okay? So, let's have, I am going to draw a graph. Then, yan, I will have this graph. Let's have a beautiful graph. And the numbers from, I want it from, let's say, I want it from here. And I think it's not beautiful line. So let's have here. So this is X. My numbers from 0 to, I think, let's have hanggang 6. No? 1, 2, 3, 1, 2, 3, 4, 5, 6. Oh, ito 7, 8. Yan. Ito 1, hanggang 1, 2, 3, 4, 5. Mahirap. 1, 2, let us make it, don't follow the lines. No? So just make like this. 1, 2, 3, 4, 5, 6, 7, up to 7. Yan. Yan. I have here a value. I want this open here. I want open here, somewhere here, open also. And I want it to be with that here, Yeah, with that here. And I want it to be open. Let me put 1, 2, 3, 4, 5, 6, 7. 2, 4, 6. Yan. 2, 4, 6. So we have let's say at this point, I want it to be like this. And then at 5, I want it to be what is a nice one? Open. I want it to be open also there. Open here. Make a beautiful open. Okay. This is the function. Make a beautiful one. That's the function. And then I want it to be yan. Okay? While I am drawing, you can eat anything you want. If you have anything, a merienda with you. Yan. And then I have here something like this. Yan. Yan, there it goes. Okay. Let us have the following questions, guys. Answer I will be calling you. Letter A, based on what we studied. Letter A. How do we answer this? Limit as x approaches 2. Guys. Of f of x. So this is the graph of f. Okay? What's name? In the list, I have, many have left already. Diola, Bartolo, because it's Carl Matthew, Micah Chavez, Maria Christine, Princess Myra. Sige, answer. Any of you? Sige, all together. This is equal to, what can you say? As x approaches 2, what is the limit of f of x? I will travel along the curve, going to 2, going to 2, going to 2. Where do I go? Chavez? Guys. What happens to the mic of these people? Pag tinatawag, mga sira ang mic. Guys. Kaubat, Azogue, Duga, Pahutnaw, Espra, Lingas, Mercado, Fernandez, Moral, Talucon, Aragosa, Bartolo, Aliera, Padrigan, ang dami ko nang tinawag, Guevara, Leones, Oy, guys. Oy, guys. Oy, do you hear me, guys? Are you hearing me? I do not know if you hear me or not. Huh? Hi, guys. So, classmate niyo nag-chat, wala raw siyang load. Just watch the recordings. Ay, it's hard to type. Check. Okay. Oh. Oh, guys. Hi, guys. Huh?
Yes, sir.
Oh, what's the limit? Oh, going to 2. From the left, where do I approach? From the right?
3, sir.
Oh, what's the limit as x approaches 2?
2 from the left, sir. 3.
From the right?
From the right, 5, sir.
Oh, what is now the limit as x approaches 2? Ay, you already didn't understand. There's so many discussions. We discussed from the beginning up to the end, showing you details. But answering question like this, you don't know. My goodness. It's useless of discussing graphical method.
DNA po, sir.
DNE does not exist. Because from the left, 3, from the right, 5, they are not equal. Therefore, collectively, does not exist. But if you're asked only from the left of 2, the answer is 3. From the right of 2, the answer is 5. Okay? Oh, yan. Letter B. If you're asked, limit. As x approaches, let's say, 5. Oh, what's the answer? From the, as x approaches 5, of f of x. Oh, what is the answer? Oh, from 5, approaches 5. So, 1, no? So, 1. Okay? Letter C, limit. As x approaches, let's say 6, approaches 6 of f of x. Oh, what's the answer? Approaches 6. Ito yung 6. Approaching 6. What's the answer? 0. Letter D. What's the limit? As x approaches, let's say, negative infinity of f of x. Oh, approaching negative infinity, meaning I will travel along this line going to the left. So, travel. Oh, where do I go? What do you notice? I keep on going down. So, negative infinity. Negative, ha? Oh, what about limit as x approaches 0? Oh, ito naman letter E. Limit as x approaches 0, positive infinity. Oh, what's the answer of f of x? Oh, going to the right. Oh, as I keep on going to the right, positive infinity. Okay? O, letter F. O, limit as x approaches, let's say, positive 2 from the left, from the right. O, what's the answer? From the right? 5 na? O, okay. Ganon. Do you understand, guys? From the graph, how to read? Huh? Let's have another one. Another graph on number 2. So this is number 1. And then number 2. We have, for number 2, you have, ito naman this one. This is the graph. That's the graph. X and then Y. 1, 2, 3, 4, 5, 6, 7, 8. Yan. 1, 2, 3, 4, 5, 6, 7, negative 1, negative 2, negative 3, yan, negative 4. So we have this. Then I have a point somewhere here. Here. Let's call this 3. Let's call this 3, 4, 5, 6, 7. Let's say this is negative 3. This is positive 2, positive 4, positive 6. This is negative. So let's say this is negative 1. Yan. Then I have this graph. Around here, I have here, let's say, I have an asymptote here. Here, I have an asymptote. And then, I have this graph. So, here, I have at this, I have this value. I have here 7. And here. But it is open there. And then I have here negative 2, negative 2. Then I have this value 5. Yan. Okay. So let me now have the graph. Let's see if you will able to read the graph that I have. Yan, that's the behavior. And then here, I have, if you have 4, I have here 5. Yan. And then, it's a hole. It's a hole again. And let me use a white one. There is a hole here. And then, the graph is now going somewhere, then reaching this value somewhere here. This is positive 2. Yan. Okay. I will emphasize that this is point. This is a point. And then I have here that point. And then here I have here this graph. Okay. What about this, guys? Ready now to answer again questions? Okay. Let's have letter A. What is the limit as x approaches to from the, let's say I want it from the negative 2. Negative 2 from the left. What is the limit of f of x as x approaches 2 from the left? Approaching past negative 2 from the left. Did it come from the left, children? I'm not answering. No, therefore does not exist because it does not come from the left. So it does not exist because there is no graph in the left, from the left. Limit as x approaches negative 2 from the right. Negative 2 from the right, children. From the right, positive 5. Letter C. Limit as x approaches from the right. So, as x approaches 0. What is the limit of f of x as x approaches 0? Positive 2. Limit as x approaches, let's say 2. Yan. Of f of x from the left, what is the limit? Children.
7.
7 po.
Oh. Yung letter B approaches negative 2 from the right, ha? Yung letter B, negative 2 from the right equals 5. Positive 2 from the left, 7. Oh. What is the limit from the left? I mean from the right. Ng 2. 7 also. So what can we say about the limit as x approaches 2? 7 also because they are equal, no? Next, we have h. Limit as x approaches 4 from the left. Guys, what about that? From the left. Ayan, when I give now another activity, kung ano naman ang score nyo. Limit as x approaches 4 from the left. What's the value? This is 4. This is 4 eh. Huh? What is the limit? Is there a limit?
Does not exist.
Limit does not exist. Pero specifically, ano yun? Going to 4. Bumababa. Although, ibig sabihin, di ba, in the instruction, you have to write the specific. Although it does not exist, but we have to write negative infinity. It means does not exist, but specifically negative infinity. A, B, C, D, E, H, I, limit as x approaches 4 from the right. What is the value? Is there a value? That's the limit. So there is, no? Positive 5. Although the limit does not exist, no? Ang conclusion niyan, IJ. Ano ang conclusion? Limit as x approaches 4. What's the value? Is there a limit? As x approaches 4. Ito does not exist. Kasi they don't have the same behavior, no? We cannot write negative infinity. We cannot write 5. It is just the D and E. The limit does not exist. Okay? What about A, B, C, D, F, H, I, J, K? What is the limit as x approaches 6 of f of x? From the left, positive 2. From the right, does not exist. Therefore, what is the totality? K, J, K, L, M, limit as x approaches 6 of f of x is equal to what? Does not exist. Okay. Yan. We're done with what? With definition of limit intuitively. So, we saw how limits existed and failed to exist in the cases of limits approached by the function values as x got close to a from either side graphically and numerically. Even though limits may fail to exist in such cases, we may consider existence of a limit on one side direction only, on one-sided direction. That is either from the right or from the left of A only. We call these one-sided limits. Take note, like for instance, letter B, the limit exists from the right as x approaches negative 2. As x approaches positive 4 from the right, the limit exists. So, if you are interested only on one side, one-sided direction of the limit, one side direction of the limit only, we have what we call one-sided limits. Okay? Yan. One-sided limits. So, one-sided limits. One-sided limits. So, how do we define one-sided limits? Intuitive. So, this is intuitive. Again, intuitive or informal. Informal. So, this is how we define. All you have to do is to change the word limit of f of x by just the left hand limit, or limit from the, instead of the limit of f of x, the left hand limit of f of x. That's it. And that is called left hand limit. Number 1, left hand limit. What do you mean by left hand limit? Left hand limit. Yan, left hand limit. Left hand limit. Left hand limit. Yan. So when you say left hand limit, this is how we define it. So if you just copy actually the definition of yung limit, may papalitan lang tayo. O, copy natin yun. Para we will be fast. Copy. You just copy this. Yan. And then meron lang tayong a little to change. Yan. Ay. Control B. So we have to, what happened? Nasira. Yan, if. Ay, merong mumu. So, let's cover that. Oops. Okay? That's it. If the values of f of x can be made as close as we like to the number L by taking the values of x sufficiently close to A from the left. Lalagyan lang natin ng word from the left. Pabuburahin na natin to. Close to A. Yan. Close to A from the left. Sufficiently close to A from the left. From the left. Yan. From the left. Yan. But not equal to A, of course. But not equal to A. To A. Yan. Then we say that, we say that, so the next meeting will have more on computations na. We say that, the limit, we say that, let's have that, say that the limit, the left hand limit, left hand limit of f of x, left hand limit is also called limit from the left. Left hand limit of f of x as x approaches what? Approaches A. Approaches A from the left of what? From the left is what? Is L. And how do we write that mathematically? Yan. And we write, then we will just copy this later. And we write f of x, f of x approaches L as what? As x approaches A from the left, or equivalently, let's have this one and make it bolder. Yan. We have limit as x approaches a from the left of f of x is equal to L. Okay? Yan. So that's how we write the definition of left-hand limit intuitively. So we just copy this and then change the left hand by the right hand. Yan. So number 2. For number 2, we just copy almost everything. And then we're going to you move here, and that's number 2. Okay, so let's have if let's I think this is double. I'm going to fix that. So if and if and so I'm going to change the word left by right, no? Lahat ng left, I'm going to change to right. Left. Yan. No more left. Then left. Okay. So we now have from the right. Then we say that naglag na, naghang na. Let's a minute. Yan, naghang. Puti na lang bumalik. So, right. Yan, right. Yan. Right. Where, what else? Right. And from the right is L. And then, we have this positive na from the right. And then finally, we have positive. Yan, positive. Okay? So that's how we write the definition of right-hand limit. So again, this is right hand. Yan, right-hand limit. Right-hand limit. So if you're interested, you are going to use this if you're interested on one side only, ha? Either from the left or from the right. But as a totality, two-sided limit. So the first one that we had, two-sided limit. Okay now, children? Huh? Guys, for your work, this is what you're going to do. You're going to make a sample graph. Let's see if you will able to do it. This is your homework activity. Let's see if you really listened well, you will able to draw the graph of this. Okay. Sketch a possible graph. Exercise. This is exercises. Exercise. Yan. You're going to post the solution. I will be posting it in Google Classroom so that you can upload there your solution. You will be uploading a file where you are going to paste your solution. So you will be given enough time. You will be submitting this till Sunday pa. Exercise. Yan, exercise. Sketch that. Sketch. You copy, ha? For the meantime. So that you can start. Sketch a possible graph. Sketch a possible graph. Yeah. So meaning, it's not really unique, no? As long as satisfying the given conditions. A possible graph. Yeah. A possible graph of the function f, of the function satisfying the given conditions. Satisfying the given conditions. The given conditions. Yeah. Okay? So, or properties. Conditions, properties. These are the given properties. Limit as x approaches -5. Make the graph beautiful, ha? You try to do it at scratch first before you finalize the graph so that your lines are straight and your curve is really curved, ha? I do not want having x-axis, y-axis deformed. Unlike my x-axis, y-axis, because I'm doing it freehand, you can use ruler because you have much time to do it. Do not submit a very bad graph. From the right, negative infinity. Limit, ito yung mga condition, as x approaches negative 3 of f of 2 of f of x is equal to 2. And then, limit, and as x approaches equals 2. Wait. Then, we have f of negative 1. F of negative 1 is equal to 5. What else? Limit, and another condition, as x approaches 1 from the left, of f of x equals negative 1. F of 1 equals positive 2. And that happens to be equal also to the limit of f of x as x approaches 1 from the right. Yan. F of 1 is equal to 2 and also equal to the limit of f of x as x approaches 1 from the right. F of 4 is equal to limit as x approaches 4 of f of x, and that is equal to 4. The function value at 4 is equal to the limit as x approaches 4 from the left and right, that is x approaches 4. And the value is negative 3, sorry. The value is negative 3. Negative 3. Limit as x approaches 6 of f of x, as x approaches 6 is
Salita ka ng
equal
salita,
to
walang internet.
1.
Na umulan,
Let me check.
naulan.
Ay, wala na. Okay na.
Dadawa, wala ka nang pinadadaan dyan.
Ano ba yan? Wala na pala internet.
Kanina ka pa nga, hindi ka nakikita ng mga estudyante. Kaya siguro di narinig.
Hindi, kakawala lang kasi kakano ko na. None. Okay? So, this is what you're going to have. You are going to submit this, okay? That's it. So, that's your activity to do. Okay? Goodbye, guys. See you next meeting.